Okay, we have some understanding of what goes on in the disk. Let's look towards the center. Of course, if you thought it was hard to figure out the structure of the disk, understanding the structure of the bulge is more difficult yet. That is the direction where there is most obstruction by dust and so on. In fact, as I said, we only realized that the Milky Way has a bar, or this was only verified. There were suspicions earlier in the past decade, so we're still learning very much about the structure of the Milky Way galaxy. In the bulge, we find, as I said, stars of varying ages with varying populations. An interesting reversal of what we're used to happens in the bulge. The oldest populations of stars in the galactic bulge turned out to have high metallicity. So they have high, relatively, concentrations of non-hydrogen and helium elements, whereas the newer stars are more metal poor. The interpretation that we put on this is that presumably early in the galaxy's history there was a burst of star formation in the bulge. This formed many hot large stars which exploded as supernovae, enriching the bulge region in metals, and therefore subsequent stars that formed shortly thereafter were metal rich. Subsequent to all of this, there must have been an infall of fresh unenriched matter from regions of the galaxy where star formation had not yet started, so where there had not been supernovae to enrich the environment. This brought in relatively low metallicity hydrogen, and subsequent generations of stars formed in the bulge would have formed in a metal-poor environment. And the bulge is one of the regions in which ongoing star formation seems to be going on as we speak right now. I think it's hard to see the bulge. Of course, the most interesting action in some sense is at the center, in the core. Seeing the core is harder still. Infrared observations allow us to peer through the dust to some extent and find that at the center of a galaxy is a dense cluster of stars, including a bunch of stars with, you'd call them type O and B, so hot blue stars, but with luminosities far exceeding what we expect for main sequence type O and B stars. Luminosities of 1 million solar luminosities per star. One interpretation of this is that these may be Wolf-Rayet stars, so older stars from a starburst episode about 10 million years ago, which are now very luminous. Remember, we're measuring their the luminosity of an OB star in the infrared. These may be having extreme infrared emissions because they are Wolf-Rayet stars. There are many puzzles about the goings-on at the center of the galaxy. For example, there is evidence for a very dense molecular cloud, but no ongoing star formation. The conditions are right for star formation, but star formation does not seem to be going on. At the center of it all, of course, sits our 3 or 4 million solar mass black hole in the center of the galaxy. Black holes in general, just a black hole in the middle of nowhere, is hard to detect. Indeed, black holes are detectable when they accrete matter. The black hole at the center of the galaxy is accreting matter at a modest rate. There is some X-ray activity. There are occasional flares, but there is not large bursts of activity, as we will see occur in some other galaxies. And to give you a sense for what infrared radiation does for us, we can watch this video courtesy of ESO. As the video starts, we see that we are looking in visible light straight at the center of the Milky Way, at the tip of the T-spout that is Sagittarius. We see the dust lanes, we can see foreground stars, but we can't see to the bulge behind the dust lane. The dust is opaque to visible light. Now, what we're going to do to remedy this is, in a minute, we're going to transit to an infrared image, and this is the visible image. We're now transiting to an infrared image, and at first sight it looks like you can see less. What's going on is the very bright blue foreground stars are rather dim in the infrared. As we zoom and zoom in and pan, you will see that the gray color of this image resolves itself into huge numbers of dim distant stars. Comparing to the image on the right, as the slider goes through, we see that the visible light image is dominated by foreground stars. In the infrared, we peer through the foreground and through the dust and are able to see the structure of the stellar bulge. This is what infrared does for us.